wanted us to learn. And I, McKensie and
Shelby Wright,
from his third period chemistry, have learned to a B level the following concepts from the first 12 chapters of our chemistry book. This is not an inclusive list, but my selection of concepts, our selection of concepts from each chapter that we will remember.
Okay, Chapter 1, Intro to Chemistry. In Chapter 1, we learned that to study the universe, chemists gather data all over to analyze matter that is brought back to the Earth. Chapter 2, Matter and Change. 2 ways to separate mixtures is by filtration and distillation. Chapter 3, Scientific Measurement. The 5 SI base units commonly used by chemists are the matter, the kilogram, the Kelvin, the second, and the mole. Chapter 4, Atomic Structure. The periodic table is helpful because it allows you to easily compare the properties of one or a group of elements to another element or group of elements. Chapter 5, Electrons and atoms. We learned that the quantum mechanical model determines the allowed energies an electron can have and how likely it is to find an electron in various locations around the nucleus. Chapter 6, the periodic table. Elements are arranged in order of increasing atomic number.
Chapter 7, Ionic and Metallic Bonding. We learned how to find the number of valence electrons. So in an atom of a representative element, you just have to look at its group number. Chapter 8, Covalent Bonding. We learned that a molecular formula shows how many atoms of each element a molecule contains. Chapter 9, Chemical Names and Formulas. To name any binary ionic compound, place the cation name first, followed by the anion. Chapter 10, Chemical Quantities. A mole of a substance is 6.02 times 10 to the 23rd power representative particles of that substance and is the SI unit for measuring the amount of a substance. Chapter 11, Chemical Reactions. A skeleton equation is a chemical equation that does not indicate the relative amounts of the reactants and products. Chapter 12, Stoichiometry. Chemists use balanced chemical equations as a basis to calculate how much reactant is needed or a product is formed in a reaction.
Yay!
Yeah.